The Lockheed P-38 Lightning looked like a warplane ripped from a science fiction novel. Twin booms, a central pod for the cockpit, and counter-rotating propellers. It was unlike anything flown by either the Allies or Axis powers. But behind its futuristic silhouette were real-world engineering challenges and flight issues that nearly cut short its legacy, especially over Europe. At high velocity, particularly in steep dives, the P-38 was plagued by a deadly aerodynamic issue, compressibility stall. As the aircraft approached roughly 0.7 Mach, shockwaves began forming over the wings and tail surfaces. The result? A terrifying nose-down pitch. The elevators lost effectiveness, and pilots were often powerless to recover. Several were lost before Lockheed introduced dive recovery flaps in later variants like the P-38J. But by then, the aircraft had gained a reputation for being treacherous near the edges of its performance envelope. Its radical twin-boom structure, while mechanically sound, hampered agility. The Lightning rolled sluggishly compared to the tighter, more responsive single-engine fighters it faced. This made it a tough contender in turning dogfights, an obvious disadvantage in close-quarter engagements. Then there were the engines. Early Allison V-1710s, fitted with turbo superchargers, were notoriously temperamental at high altitudes. In Europe's frigid skies, poor intercooling often led to engine knock, and the constant heat cycling would wear down turbos, leading to frequent failures. Worst of all, an engine failure didn't just reduce power. It created a dangerous imbalance. The wide engine spacing made flying on one motor a nightmare. Landing safely under those conditions was more about luck than skill. The pilot's experience wasn't much better. Cabin heat was minimal, often leaving flyers to suffer with numb fingers or outright frostbite during long, high-altitude flights. Rearward visibility was limited by canopy framing, and maintenance crews dreaded working on it. The P-38 demanded far more upkeep than its single-engine counterparts, and many field repairs needed factory intervention. Even the tricycle landing gear, revolutionary at the time, initially confused ground crews unfamiliar with the design. So, why did America's two top-scoring aces, Richard Bong and Thomas McGuire, choose this aircraft? It started with the nose-mounted armament, 4.50 caliber machine guns and a 20mm cannon, all aligned and centered. Unlike wing-mounted guns that needed convergence adjustments, the Lightning delivered its full firepower across all distances. For sharpshooters like Bong and McGuire, this meant precision firepower that could tear through targets in a single pass. Then came its unmatched range. With over 400 gallons of internal fuel and drop tanks, the P-38 could fly missions exceeding 2,000 miles, something no other American fighter could match early in the war. This range let Bong and McGuire patrol vast stretches of the Pacific, strike deep behind enemy lines, or escort bombers without needing forward bases. At high altitudes, especially in the warmer Pacific air, the P-38 came alive. Turbochargers performed more reliably, and the aircraft could sustain power and speed above 20,000 feet, ideal for high-speed boom and zoom attacks. Its climb rate, around 4,000 feet per minute, gave pilots the ability to dictate the terms of engagement. And while the roll rate was limited, the aircraft was remarkably stable during gunnery runs. Less yaw, less shake, just smooth, accurate shooting. Even its greatest weakness, engine asymmetry, was a form of insurance. While losing one engine made flying difficult, the P-38 could still limp home. Many pilots, including McGuire himself, survived missions thanks to this feature. But it wasn't just about hardware. The P-38 faced stiff challenges in Europe: cold air, powerful German fighters, and tightly regulated escort formations that didn't play to its strengths. In the Pacific, however, it excelled. The warm, humid environment helped mitigate engine problems. Dogfights often involved slower, lightly built Japanese planes, ideal targets for the P-38's speed and guns. More importantly, Pacific pilots weren't tied down. Bong and McGuire were granted flexibility, flying intercepts, ambushes, and roaming patrols. They mastered the aircraft's quirks, adapted their tactics, and maximized its advantages. They didn't fight against the P-38's flaws. They flew around them. With over 70 confirmed kills between them, they became legends. Was the P-38 a failure? Only if judged by the wrong criteria. In Europe's cold, high-altitude battlefield, it struggled. But in the Pacific, where endurance, firepower, and energy retention were paramount, it dominated. The light was right hand under right size. It became a lethal instrument, a complex, flawed marvel that helped turn the tide in the Pacific Air War. Thanks for watching. Subscribe and like for more informative videos.